Hey guys, Steve here again with Diabase Engineering. So what we're going to talk about today is how to get good multi-material prints out of the H-Series machine. The H-Series is very versatile, but with that versatility comes complexity. So the more ways that you plan on using the machine, the more you're going to need to understand the details of how it works, and the more organized you're going to need to be in your setups. So that's everything from your slicer settings for your different materials to your workspace and the tools that you have available and ready to use, and your firmware configurations. All these things make a big difference to the user experience of working with a multifunctional machine like this. In this video, we are picking up where we left off from tutorial 1. So if you haven't watched those videos, please go back and do so. There's a lot of useful information in there. But we dialed in our offsets for all of our tools. We touched off our tools for our Z offset on a piece of cigarette paper, and then for our X and Y offsets, we dialed those in by printing a hollow cylinder and then probing the inside of the cylinder. So the machine's ready to go, but before we just load a multi-material print and hit go, there's a whole lot we have to talk about, starting with our software toolchain. So generally, we're going to have our part in our modeling software. This is our normal starting point for really any build. So for this video, this is our end goal, to print this multi-material part. And this is just a flange that holds the arrows in my quiver. The old part was a little worn out and dry rotted, so I thought I'd print a new one and make use of it as an example build for this video. So it's a 3-material print, but before we dive into the details here, let's just talk about the process that we're going to go through in order to get from this model to a physical object in our hand. So we're starting off here in the modeling software, and this is where we're going to define our coordinate system for the build, but it's also where we're going to define how the differing materials mate with each other and how they interface, whether they're just coincident or whether there's some overlap. So we define our model geometry here, and then we'll export an STL into our slicing software. So in this case, Simplify 3D, and I don't have the model in yet. We'll walk through that process. But this is where we're going to define most of the parameters of our process. So everything from our nozzle diameter to our extrusion width, our temperatures, our layer heights, the scripts, these custom scripts that we send to the machine in order to get it to do some special things that we want. Our speeds, all of these things will be done in the slicing software, and then from there we'll export our G-code and then go to our post-processor. So this is the Diabase printing wizard, and here this is a piece of software that just combs through that G-code and makes some changes to it that are specific to the needs of the H-Series machine. And it also gives us a few more knobs to turn, a few more parameters that we can change that Simplify doesn't allow. So from here, we'll process the file, output another G-code file, and then send that to our machine. But we're not done at that point. So we can load the file into our controller, but before we hit go, there are a lot of definitions that we need to make here in our software. So from our offsets to our system files, these are all the files that the machine uses when it's interpreting the G-code that we've sent it. So for things like the tool changes, the timing of the prime cycle and of the cleaning and retraction settings, all those things can be modified in here as well. So we have all of these knobs to turn, and we're not going to go through all of them in this video, but we'll try to go through the major ones that will get you going on multi-material prints. So we're going to take a few steps to get to our multi-material print. We're going to start by doing a single material print with each of the specific tool heads and materials we're going to use for that multi-material print, but just one at a time. A surefire way to get frustrated with multi-material printing is by just launching into it and not having your settings dialed in for each of the tool heads and each of the materials. After that, we'll do a simple multi-material print that's just a series of concentric cylinders, and at that point we'll dial in our tool change settings. So that's our timing, our retraction settings, those sorts of things. And we can also double check with those concentric cylinders that our tool offsets are correctly set. And then at that point we'll start to look at doing the actual multi-material print that is our goal. So to start with, we need to decide what materials we're going to use and choose which tool heads we're going to put them in our machine. So for this part, I want this region, this component here, to be quite flexible. So I'm going to use Cheetah, which is a 95A-ish TPU. And then for this component here, this is a rigid section that's meant to stiffen the back portion of the part. I'm going to use PETG for that. And then this yellow section here is just support material that I'm going to use PVA for. So those are my materials. And going back to Simplify 3D, I need to decide which tool heads to use them in. And thinking about the H-series machine, I'm going to use the softest material, the most tacky material in T3, because that has the shortest path from the filament cabinet down to the print head. Now, on this machine, I actually have Filament Assist installed, so it doesn't really matter. But for those of you that don't have it, you'll want to typically use your TPUs in Tool 3. And then PVA I'll use in Tool 4. These two I have standard hot ends installed. In T5 I have an HT hot end installed. So T5 is going to be PETG, T4 PVA, T3 Cheetah. Now when we're choosing the model to do our single material print in order to dial in our settings, we want to choose something that has difficult features so we can actually see if our print settings are good. So we could use something like this, which is a little toy boat that a lot of people use to benchmark 3D printers. And I use this to confirm my settings for PETG. But I'm not going to use it for the other materials because it takes quite a bit of time and it's a little bit of overkill as well. So what we'll use instead is this part. It has a few thin walls that will show us if our retraction settings are good and our layer changes work well. And then it has a hole there that will show us if we have problems with curl. And then that feature across the top will show us if we have problems with bridging. Then this little jog out the back will show any trouble with ringing. So I actually already printed this part with Tool 4 and Tool 5. So those guys are already dialed in, but we'll walk through dialing in Tool 3, which is our TPU. So let's talk a little bit about the different settings that I have defined for these different materials. So over here in my processes window, I have this group 1 defined. Now, grouping in Simplify 3D is a topic of its own. It is very important for multi-material printing, so it's worth taking some time to understand. The basics are any parameters that are the same in multiple processes, when you group them, will change together. So when you make a change to a parameter in one process, it will update in the other. So say I double click here on my T3 process and go to my layer height. I have that set at 0.15. And if I check T4, my layer height is also set to 0.15. And that was the case when I grouped these processes. So now if I were to change that to 0.2 and save it, now I look at my layer height in my T3 process, that also changed to 0.2. So that is extremely useful when you're dealing with multiple tool heads and multiple materials, especially in our case where we have these different tool heads that we may want to use in the same process. So right now I'm in my T3 process, but I have all of my T1 through T5 tool heads available within this process. So it's a little bit confusing, but the reason that we do that is we can use different tool heads within a process for different areas of the print. So say I want a skirt or a brim or a raft of a different material when I'm going to print, in this case, say I'm going to print cheetah with T3, but I wanted to use support material of T4 and use automatically generated support material, then I could do that here. I could say generate support material and choose my T4 print head. Now I'm not going to do that in this case because I have separate models designed in for support material and then two materials for my part. But it's worth taking note of that you can change the settings for your different tool heads within one process, and if you have them grouped ahead of time, then those settings will change in your other processes within the group. So again, here, if I were to change my temperature for T4 while I'm in my T3 process, it will update in my T4 and my T5 process as well, but only for tool 4. So again, a little bit confusing, but after using it for a while, you'll get the hang of it. Okay, again, so let's look at our settings. And I'm not going to go through all of the settings here, but we'll look at a few of the major ones that we typically change in order to get started dialing in your print settings. So for T3, in this case, I have my nozzle diameter set correctly to 0.4. My extrusion multiplier is at 1.05. Extrusion multiplier is one of those key adjustments that you'll make. My retraction distance I have set to 6 millimeters. Extrusion width actually can be very important too, especially when you're trying to dial in overhangs and kind of surface roughness. So the larger this value, the more the material is going to be forced to bulge out away from the orifice of the nozzle. And that can be helpful in some cases. You can get better fill and fewer voids in your part, but it also can cause problems. So the automatic value would be 0.48. So that's what Simplify would assume if I didn't want to enter my own value. But in this case, I'm using 0.42. I've found that to work better with Cheetah. And then retraction distance is another big one. So for more amorphous materials like TPUs or PVA, you'll see this as well. We use higher retraction. So 6 millimeters is how much the extruder will retract the filament when we go to make a travel move. And we can define the length of that travel move in one of these other tabs. We won't go into that just now. So then for my layer height, I have 0.15 set. Top solid layers is a very important one for TPUs. I have that set to 4. Bottom solid layers to 2, that's fine. Then since we're using a prime cycle, we don't need to do a skirt or a brim to make sure that the nozzle is primed. We definitely don't need to use a prime pillar or an ooze shield. Then our infill, we want to make sure that we have the same extruder set for our infill as our other features. The infill pattern, rectilinear is fine in this case. Infill percentage, 80% means that this portion of the part, so this is the rubbery portion of my clamp, and I want it to be pretty durable, tough, and fairly rigid for the stiffness of the TPU, so 80% will be fine there. So infill extrusion width is another one that it can be very useful with TPUs if you're doing, especially if you're doing low fill percentage. It can help to bridge those low infill gaps. Let's see. No support material needed on this. Then Temperature, of course, is another key factor. So in this case, for T3, I'm going to use 233C for my TPU. Cooling, I do have cooling fans that I set up on these extruders, but I have them currently wired directly into my extruder cooling fan, so I don't need to control the speed right now. In a later video, we'll show you how to set those up to your actual cooling fan lines. So our scripts, this is where we can send custom code to our printer at, say, the start of the print, the end of the print, or at layer changes, tool changes. This is extremely useful, but it also requires that you learn some G-code and understand how the H-series responds to the G-code that you'll put in here. So now, there are a few things that I've added to these scripts that would not be in the standard factory file that we sent out with the machines. One of them is this line here. This defines the motor current percentage for the extruders and filament assist. So this 65 here, this last value, I'm setting the motor current percentage lower than it is set in the firmware. So there's the actual motor current that's defined in a configuration file in the firmware, which I can show you later. But then we can also define temporarily a percentage of that motor current to send to the motors. And that's what I'm doing here. I'm setting it at 65%. So using the filament assist motors for different materials can require a little bit of dialing in too. So if you have that motor current set too high, the filament assist motor can, in some circumstances, fight your extruder and cause problems for your print. So in this case, I'm setting it low, and then you'll see in my ending script, I'm setting it back to 100% to make it useful for loading and unloading filament. And then this M0H1 at the end here, that is that tells the machine to stop. It basically puts all the motors into idle and turns all the heaters off. But there are some heaters that you will not want to turn off every time that you run a print, such as your filament cabinet and sometimes your bed heater. So your bed heater would be H0 and your filament cabinet is H1. So if you want those two heaters to stay on, you can put this line in your ending script, which will do just that for you. In my case, I don't care about my heated bed at the moment. I'm just going to leave my filament cabinet heater on. And then our printing speeds. So when you're doing multi-material prints, you do often have to run slower than with single material prints because you're trying to ensure a good bond between differing materials, where the adhesion between those materials often isn't as good as the adhesion of the material to itself. Let's see. Tool change retraction will be very important for multi-material prints, but we won't spend a lot of time on it just yet. For print quality, there are a couple settings here that can be important. So if you have minimum travel for a retraction set, then any travel moves that are smaller than this value, the machine won't do a retraction move for. It'll just quickly move the print head over. So especially for TPUs, that can cause problems. You can get a lot of stringing, but it can be very useful for increasing your print speeds. If you have long retraction moves, that takes time. Every time you do a travel move, if you do retraction, you're adding time to your print. And then forced retraction between layers, it's a similar situation. You can get little zits on your print that come from material oozing just in the time that it takes for the machine to move from one layer height to the next, especially if you have back in your layer tab, if you have this use random start points for all parameters, that means that it's not just going to start and stop at the same point. When it does that layer change move, it's going to move to another point on the print. So whether or not you use retraction for that will be defined by those two checkboxes. This avoid crossing outline for travel movements can be very useful for getting very clean walls, but we're not going to use it here because we're actually trying to dial in our retraction settings, and it can hide problems with those settings. So, okay, we're going to say that's good. So since we're just doing a single material print, we need to just select the one process that we're going to use, then go to Select Models. I have the model already selected here as quick test. We want to make sure that you don't have any other models selected by accident. Say OK, prepare to print. So our process is already selected there. Save toolpaths, quick test T3. Yes. Now we'll open our Diabase postprocessor and say we're only using T3, so that's the one we want our auto clean checkbox selected. We can allow these other ones to be at their standby temperature. That's fine. Now we go here to select the file for post-processing. Next. And just skip through this right now. I'll tell you more about this the next time we go through it for a multi-material print. Overwrite the old file, yes. Then we'll go to our machine controller and say upload and start. Select our G-code, say OK. And now the machine will just start without any confirmation. So if we had gone to our G-code files, uploaded the G-code file here, then we would have had to go find that G-code file and click Start Print here. So that print is now starting. There are multiple things we can talk about here. So on the left-hand side here, we have these different tabs. The machine control tab has our jog buttons and our extrude and retract buttons for loading and unloading filament, that sort of thing. And then the next one down is our job status. So that's where we'll typically want to be when we start a print, because there are a few things that are very useful here. If we started a print and didn't have our nozzle offset perfectly defined, we could use these baby stepping buttons to jog the machine up or down during the print in order to get it to the right height. Now, at the end of that print, you want to go and recheck your nozzle offset and get rid of this baby stepping. You don't want to rely too heavily on baby stepping in order to get your print adhering well to the bed, especially if you're planning on doing multi-material prints. This is also where we can change our speed factor, so we can adjust the speed during a print, and then the same thing with extrusion factors. Right now, the extruder labels aren't all that intuitive. For machines with 3 print heads installed and 2 spindles, that's a pretty standard configuration for machines that we're sending out. Tools 1 and 2 are your spindles, and then tools 3 through 5 are your extruders. So here, these extrusion factors just count up from 0. So extruder 0 is your first extruder. So in our case, that's tool 3. Extruder 1 is tool 4. Extruder 2 is tool 5. And then extruder 3 is your filament assist multiplier. Now, we'll give you updates as we make improvements to the firmware. But right now, that's how you'll have to remember it. They just count up from the lowest number extruder that you have. If you had tools 1 through 5, extruder 0 would actually be tool 1. So it's a little bit confusing, but we'll improve that as we go. GCode Console is where we can type in G-code and send it directly to the machine. We definitely don't want to do that while it's printing. It will respond to G-code that we send. But there are times when sending commands from this area of the controller is very useful. Our GCode files here, that's pretty self-explanatory. Macros, these can be extremely useful. The machine typically comes with a few macros loaded on it. This prime function will prime all the extruders. This warm-up macro is useful when you haven't run the machine for a while. If the machine's been sitting, the bearing seals can get a little bit sticky, so it's a good idea to run this before you run your file. And our offsets page, we already talked a little bit about this in tutorial 1, so we won't go through it now. And then settings. So here's where you'll interact with the firmware of the machine. So when you go to update your firmware or to load new files that we send you, you'll do it through this dialog here. Now, under this System Editor tab, this is where all of the system files for the machine are stored, and where we actually will make some modifications to get the machine dialed in for multi-material prints. So to start with, the machine's going to come down and probe the bed, and it's going to do that because of what we have in our G-code. So let's look at this G-code file. Let's look at it from our directory so that we're not opening the file that the machine's actually running. So this is the code that was output by the Diabase postprocessor. And at the top, you can see we have some statistics about the file. And then if we scroll down near the top of the code, you can see a couple commands here. This G28 is a home all command. And then this G32 is a probe Z and calculate Z plane command. So let's go back to the controller and then come down to our settings tab. And then within settings, let's go to System Editor. So this is where all of the system files are stored for the machine. So these are the files that the machine uses to interpret the G-code that we're sending it from Simplify 3D and from our postprocessor. So when we ran that G28 command, that's our home all command. So that causes the firmware to run this home all.g file. So if we look inside there, this code is what the machine will do when it sees that G28 command. And that G32 command will cause the machine to run this bed.g file. And in this case, we have the machine configured to probe the bed at 9 points. Now, this doesn't mean anything to the machine. It's just a comment for the sake of the user. But this T10 command will cause the machine to bring up tool 10. And then this M557 command is telling the machine what points to probe. And so in our case, we have it set for negative 180 in X to 180, and then in Y, negative 80 to 80. And our spacing then is 180 in X and 80 in Y. So that'll be 9 points. So if we wanted to probe the bed just at a smaller grid, say half this size, say negative 90 and 90, if we're just doing a small print, and then we change this guy to 90. So that would be, let's say 80. So this would be a square 9-point grid that we would probe instead of doing the entire bed as we just did. So this is where you can make those definitions. Okay, so that print finished, and it looks pretty good. But there are some places where we have some little defects on the surface. So I'm going to make some changes to my settings, and we'll try it again. So I'm going to open my T3 process and come into my retraction settings and increase that slightly. So let's say 7 millimeters of retraction. Let's see if that gets us there. So in this case, though, let's just go to upload this GCode file directly and not say upload and start. And then let's go into our settings and change that bed.g file. So I'm going to just copy this line and then comment this out. So that semicolon just means that the machine's going to ignore that portion of code. And I'm going to define this as -80, 80, and this guy 80. So that should probe a square print region instead of the entire bed. So say save changes. I will go to back to our GCode files and say run, yes. So again, that G28 code will cause the machine to home all the axes, and now it'll come down, probe one point in the center of the bed, and then it'll probe the grid that we defined. Okay, that print finished, and it looks like the changes that we made had a good effect, but we're still not quite there. We still have some defects on, especially on the inside surface where we're making our layer changes. So let's go back to our T3 process, and let's come down to this checkbox here, coast at end. So what this does is it causes the extruder to stop pushing filament a small distance before the end of the trace that it's printing. And with TPUs and other amorphous materials, this can be helpful to relieve the pressure before the end of the trace. Sometimes when you're doing layer changes and you're getting these little zits on the outside of your part, this function can help relieve that. So let's try 0.5 millimeters for it and run another print. All right, that print finished, and I'm pretty happy with the result. So I'm going to come into Simplify, and the first thing I'm going to do is save this factory file. So save factory file as 3 material factory. That's fine. I'll just overwrite the one that I already have. But then I'm also going to come in here and save these processes as profiles. So I'm going to save as new T3-cheetah, same name as my process. I'll do the same thing here for PDA. And I'm doing this in order to be able to use these processes in other factory files. So say I built a factory file with some other models, and I remembered that I had a process that worked really well with PETG. So then I can grab this FFF profile, import it into that other factory file, and make use of it there. So clearly it's not always that easy to dial in your print settings for a new material from scratch. So in order to do this more quickly and to not have to change your settings, print one part, then make modifications again, print another part, one way to deal with this is to print an array of parts with different processes all at once. So let me open another factory file here. So in this case, I have 15 parts here, and I've set up different processes for each of these. So Simplify allows you to just come in here, take a process that you've already created, hit Control-C, Control-V, and you can copy that process, then make modifications to the settings of that process and select the particular model that you want. So when we're doing this, we want to be careful that when we output our code, so we say prepare to print, we have all those processes. It's going to select all these models. But rather than just printing that all at once, like I just did, we're going to say prepare to print, and then rather than saying continuous printing layer by layer, we're going to say sequential printing object by object. Now, this max height clearance is just saying up to what height do you want to use sequential printing, and in this case, we just want to print the entire part, so 20 millimeters will be plenty of room for that. But we do need to be careful that we leave enough room between parts that the tool head doesn't collide with another part while it's printing one of them. So that's a very useful way to dial in your settings, though, because you can make changes. Say you're not sure what direction to go with your retraction. So you had it set at 4, you wanted to try 3, 2, 1, and then up to, say, 10 millimeters of retraction. So you could do that across one row, and then try different temperature settings across another row, different layer heights even across another row. So this way you can set the print up, let it run, come back, choose the part that looks the best, and then use that as your baseline to even run another array of parts. So this can save you a lot of time when you're starting from scratch with a new material.